Sorry, the network knocked me off.
No problem, sir. Welcome.
Yeah. Okay. So the same thing when you look at the people that don't smoke, no smoking, no. There are 1,000. That 1,000 is the C plus D. You know, that 5 is C. The 995 is the D. So it's the 5 plus 995 that give you 1,000. That's why the formula is say all relative risk is A over A plus B, everything over C plus D, the way it is. So A all over A plus B, that is the risk, 25 over 500, that is the risk among smokers, risk among the exposed. Then 5 over 995, which is the C over C plus D, is the risk of lung cancer among the people that are not exposed. So for us to prove that lung cancer is the one causing it, contribute to smoking, we have to now divide the risk among the smoker. We make it as the numerator by the risk among the non-smoker, denominator. We expect it to be bigger. So can you see? So when you solve it, I give you 10. So what this one telling you is that the risk of smoking is 10 times more than that of 10 times among the smoking risk of lung cancer, rather. The risk of lung cancer is 10 times among the smoker than non-smoker. That is greater 10 times among the smoker than the non-smoker. So smokers are 10 times more likely to have lung cancer. Yeah. So we are not saying that. They are not saying that the non-smoker cannot have lung cancer. The likelihood is higher 10 times among smokers. That is relative. Can you see now? That's why I call it measure of association. It's able to, so association between smoking and lung cancer is able to quantify it. For this data, we can calculate odds ratio also. But this scenario, is relatively for. You know, the computer can calculate it for you. That's why you can calculate it because the figure arrangement is here. But the problem there is that for if it is a cohort study, something that you are looking to the future, cohort study, it's wrong for you to calculate relative odds ratio. However, if you are running logistic regression, it will give you odds ratio. You're going to see later, odds ratio is a proxy. The reason for using odds ratio instead of relative risk. Odds ratio is a proxy to relative risk. Proxy means when you cannot do relative risk, you use something that you can use as alternative. So let's run it. Let's run this one before we move to the next one. Who share smoking lung cancer? That's the name of the something. Who will share? Smoking lung cancer. That's the name of the file. Who is ready here?
Okay, let me share.
Okay.
So can you see now?
It's coming up. It has not come up. It's coming up.
What's happening?
You have not. You are supposed to
This
have closed that SPSS something before you. So it's okay. Yes, that's it. So the data is making noise. You have to mute yourself. Mute yourself. You see that the data set very simple. The way it's enter is enter. You know there are two groups: smoker, non-smoker. So you enter it in series. So after the serial number, the smoking. So we have coded smoking 1, non-smoking 2. So I want to sound a note of warning. You know, sometimes we say we can code when you are dealing with dichotomous variable. You can code 1 and 2 or 1 and 0. So when you are doing this type of analysis, where relative risk, odds ratio, and other one we're going to do later, sensitivity, specificity, that's under diagnosing and screening test. You are advised to code 1 and 2, now 1 and 0. Because if you remember, each of the cell, 4 cell has address. Whenever you are doing cross tabulation 2 by 2 conjugate, it's better you code 1, 2, 1, 2. The one that has yes 1, the no 2, yes 1, no 2. If you go and code yes 1, no 0, so you know that figure, if you arrange according to figure, 0 will come before 1. So I mean, imagine you have coded someone that has like smoking 0, 1, depending on not smoking 0. So by the time the computer, it will put that 0 first because that is the one that will come before 1. That's why when you are coding it, the 1, 2, 1, 2. So the people that are smoking coded 1, the no coded 2, the lung cancer coded 1, no lung cancer coded 2. That's what it's doing. Leave all those other logistics is when I use them to run logistics. Those one is dummy for logistics. That one you have to convert to 1, 0 when you want to run for logistics. Can you see, imagine the same data? You have to put 1, yes, 1, and no 0 when you want to use to run logistic regression. Then when you want to do the cross tabulation to calculate the odd ratio stuff, you have to code the 1 and 2. You want to know what I said, and if you click on that one, if you scroll down, you go to see this one, smoking and lung cancer, they are 1 and 2. While the other one, the logistic, smoking logistic, lung cancer logistic, I coded 1, 0. So the issue there is that it's in parallel. As you enter when you finish enter the smoking, the name of the people that are not smoking. So let's go to analyze. Analyze. So you stop sharing.
Sorry, my internet disconnected
Sorry.
from the laptop. So let me try and connect it back.
Okay.
Okay. Okay, Professor.
Yes. It's Dr. Dimas, you can share your own now if he's trying to.
I'm sharing now.
Oh, yeah, share it. Okay. Yes, great. So you go to analyze. Analyze. Go to descriptive statistics. Cross tab. Anything that has to do with contingency table is cross tabulation. Go to descriptive, you go to cross tab. So smoking will be the exposure. For that, yes, that will be on the row. Okay. Then lung cancer. Yes. Now go to statistics. Click on statistics. Click on it now. You double click on it. So you look for risk. You see lower right border. Risk. After cap. You click continue. Okay. So you have to share. Yes. Or if you go to your window, you may open it now, you remember. Go to your window, you may open the result. If you go to your window hub beside help, you can open the result. Click on window.
Okay.
Window that window beside help, before help. You didn't see it. So click on that one, output viewer one. Maybe it will change. Okay, it's you that within. So stop sharing and share. It's not showing us. Stop sharing and not share that view. So scroll up. Let's see. You will see the way we arrange the thing on the table, the way it comes. So scroll up. You will see. Scroll up means that let's go down. Is it down or now? So that we'll see what is down. It's okay. So the computer, I told you, is garbage in, garbage out. With this data, I should feed in this data now. The computer does not know. Is it case control study you are doing? Is it cohort study? It doesn't know. What it knows is that you are putting data. So possibly, and you have asked for risk. Both of them are measure of risk. So it has calculated relative risk for you and odds ratio. The first one is odds ratio calculated. But leave that one. The second one, when you say for cohort lung cancer, yes, that is it. Can you see the 10? That's what we calculated. Relative risk 10. So the only thing we didn't calculate with hand, which is we have to calculate with hand, is a little bit rigorous, waste time, is the confidence interval, the 95% confidence interval. The lower value is 3.851 and the upper value is 25.965. Now, how do we know? We have already seen that the odds ratio is 10. How do we know that odds ratio, relative risk is 10? This relative risk of 10, is this significant or not? You can know through confidence interval. I've already told you, confidence interval will give you threefold information. Whether the thing is significant or not, it gives you the quantification, which is 10. It gives you the range of value within which you can find population value. It can also tell you if it's significant or not. You remember when we're talking about the mean, we say if the confidence interval crosses 0, it's not significant. We will not, because that one is about mean difference. If you remove one mean from the other mean, if both of them are equal, you give it 0. No hypothesis say there's no difference in the two means. If you remove, there's no difference between 60 and 60. You say 60 minus 60, it gives you 0. So we know that the 0 mean there's no difference. So if the confidence interval crosses 0, we know that it's not significant. It's the same here, but the logic here, it's not about subtraction, it's about division. How did you calculate the relative risk? It's by dividing the risk among the exposed by the risk among the non-exposed. So it's the division. If the risk among the exposed is 10, and the risk among is 0.5, and the risk among the non-exposed is 0.5. If you divide 0.5 by 0.5, it give you 1. If the risks are the same, it give you 1. It means that non-hypothesis is true, where the risk ratio is 1. It is when both numerator and denominator, the risk among the exposed and non-exposed is the same. That shows there is no association between the smoking and lung cancer. So that is why whenever the interpretation of this confidence interval is when it crosses 1. Whenever the confidence interval crosses 1, it is not significant. If let's say now the confidence interval starts with 0 point something, before the lower value is 0 point something, then the upper value is 25, you know that it's not significant. Because what is telling you that in the population is a range of value. That is, this range in the population, the real value will be in between these two values I give you. If one of the value is start from 0.8, 0.9, in now reach 1, before it came into move. Gumen, please. Gumen, mute yourself, please. Khadija Gumen, mute yourself. So if the confidence interval crosses 1, it means that it's not significant, because by crossing 1, it means that 1 is one of the possible values that in the population. So that's what, if it's 1, it means that there's no association. Once that 1 is there in the range of value, and for it to be 1, it must have started from 0 point something before it moved to anything after 1. You know that it's not significant. But if it's from the way it is now, it's significant because it has not crossed 1. It's crossed it starts from 3 point something to 25 point something. If let's say also, if it starts from minus 25 to minus 3 point something, it's still significant because let's say now, if let's say we divide the way we did it, we compare, we put the odd, we arrange it in a different way. So it will not be, because if let's say we divide the risk among the unexposed by the risk among the exposed. So you know the risk among the unexposed is smaller. We divide it now. It gives us odd ratio will be in relatively will be 0 point something. You know, if the numerator is smaller than the denominator, it will be 0 point something. So it will still be significant in this case because the confidence interval will now give us something like 0 point something to 0 point something. It will not still cross 1. So that is the interpretation of confidence interval here. Before we still talk much about it, let's stop sharing. Let's move further to go and discuss odds ratio. Stop sharing. Thank you. Now, we have demonstrated if you look at the way we calculated at 10.474, the odds ratio, so it's the same thing we see there. So these are just the steps in UCSPSS to run it. Now let's talk example 2. This one demonstrates the odds ratio. We just demonstrated relative risk. This example of 200 patients treated in a hospital, 50 have lung cancer. Of these patients, 45 are smokers. Of the remaining 150 patients, 60 are smokers. What is the odds ratio for smoking? So of 200, the people that have lung cancer are 50. 150 did not have. That's why they get case control. 50 cases of lung cancer. And now look for other people, 150, they don't have lung cancer. Can you see now? Vertical. The exposure along the horizontal. Let's now look. Out of the 50 that have lung cancer, 45 yes to smoking, 5 no to smoking. So 45 smoke. Only 5 did not smoke. Farouk, you are dissolving hair. So of the 150 that don't have lung cancer, 60 smoked, 90 did not smoke. If you look at the first one, the relative risk we calculated, we are interested in among the people that smoke, how many people develop lung cancer? Among the people that did not smoke, how many people develop lung cancer? So among the exposures, different category, the two categories of exposure, smoke, not smoke, how many of them develop the outcome? That was what we did. But here is among the people that have the disease, among the 50 that have the disease, how many smoke before? Among the people that don't have the disease, how many people smoke before? Can you see now? You are not even interested in number of people that smoke before anyway. What you are interested in is the disease, and the disease has happened. The best you can do now is that to ask question, oh, did you smoke in the past? Did you smoke? You know, it's different from the relative risk, the other one we did, where you start with people that are smoking. You can be sure that this one is a smoker. They have recruited this one as a chain smoker, and this one is not a smoker. And you follow them up objectively, you know the people that develop the lung cancer, the people that did not develop. That is for cohort. That's when you calculate relatively. Yeah, the disease has occurred. You don't know how they got the disease anyway. You are just asking, did you smoke? It's whatever they tell you. And did you smoke? Or you are not smoking? Or you have people that have the disease, do you smoke? People that don't have the disease, you ask them if they smoke also. It's just for you to have that idea. Now, how do you calculate it? You see, you just say AD over BC. But if you follow it systematically, for example, now, let's even talk about what is the probability. You know, you can conceptualize odds from probability, from risk to probability. You can say among the people that have lung cancer, what is the proportion that smoke? So you can unmute and answer, because this one is not a big figure, it's something you can easily calculate. So what percentage smoke? Or just, you may not even calculate the percentage. Say this over this. What percentage smoke? 20. The percentage smoke will be, is 45 over 50 now.
Yes, sir, 90%.
Yeah. Thank you. So now that is they know that percentage of 44 over 50 is risk. What of the percentage that did not smoke, which is 1 all over the one that smoked, the one that did not smoke? You know, the way you calculate odd is risk over 1 minus risk. 1 minus risk that the thing did not happen. So if the proportion, the risk is 45 over 50, the 1 minus risk is 50 over 50. If you divide 45 over 50 by 50 over 50, what do you think will give you? 45 over 50 by 50 over 50. So I didn't put it there. Just want you to. Over 5 over 50. What does it give you? It gives you 45 over 5. Abi, try it now. Is it not true? Because if you say 45 over 50 times divided by 50 over 50, when you want to solve it, you now say 45 over 50 times, it will become 50 over 5. You change, when you change negative to division to times, give you 50 over 5. 50 will cancel 50. So that's so that the odds of smoking among the people that have lung cancer is 45 over 5. Is it clear? The odds of smoking among the people that have cancer is 45 over 5. The same thing, the odds of smoking among the people that don't have lung cancer is 60 over 90. So if you look at it, 44 over 5 is A.
Sir?
I say 45/5 is A over B. 60/19 is C over, no, 45 is, this one is A over C. This one is B over D. So when we say odd ratio, now, which is 45/5, we want to compare the two odd. The odd of smoking among the people that have lung, because the people that have lung cancer should smoke more than the people that don't have lung. If the smoking is more than, so 45/5 divided by 60/19. So it will give you 45. You know, if you now want to times it out, it will now give you 45 times 19 over 60 times 5. That's so in ordinary algebra. When do you find difficult? There is 13.5. The odd ratio is 13.5. If we calculate relative risk for the same thing, it gives you 8.14. Though in this situation, you cannot calculate, but the computer will calculate it for you. They are calculated here because I want to use to explain some things for you. So let's somebody apart from Messi, who will share the other one. The second one, okay, Messi should do it because there's something I want to demonstrate here. And well, it doesn't really matter. Let somebody else. If somebody else here is ready, this one is lung cancer. Okay, asthma, right? Okay, lung cancer, smoke. The other one is the first one we did is smoking lung cancer. This one, the file lung cancer smoked. So that's what we should share. Great. So go to, it's the same way we did the other time, the way you enter it. This one you are seeing yes, 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 no. If you want to, wait, if you go to view, you go to see, it's because we went to value label. Yeah, click on check it. It's 1, 1, 2, you'll be seeing there. So it the matter. Me, I don't like with that yes, yes, I don't like it. I prefer it like this. It depends on what you want. So yeah, go to analyze. Descriptive, explore. Okay, sorry, constabulate, yes. What did you do now? I better go back. It's not descriptive. Descriptive statistics, you go cross tab, yes. So lung cancer will be, smoke will be along the row, lung cancer along the column. But smoke is the exposure. Yes, go to statistics. Risk. Risk. Click on risk. In the express, it will not tell you the call both of them risk. Continue. Continue. Okay. Stop sharing and share your results. Stop sharing and share your result. Thank you. So large. So you will see. You will see odd ratio 30.5. If you see, if it's also calculate relative risk for it. just like the way I calculated for the other one. So the interpretation is the same. The confidence interval is 5.067 to 35.970. So is it significant or not? You can mount an answer. Is it significant or not? Answer now.
It is, sir.
Yeah, it is. Why? Why?
So you said the odds ratio.
It's significant. How is it significant?
It's not
Why?
significant.
Is it that it's significant or it's not significant?
It's not significant because it's above 0.
What is above 0 there?
The confidence interval.
You didn't get it.
Okay.
I didn't get the explanation I gave. Who got the explanation? The house. Because that is the issue of 0 is for mean, difference between mean. I just make reference for that. That the way we usually say for the mean. And the reason is that in calculation on the mean, you are looking at difference between two means. So the operator there is minus, is subtraction. If you transcribe two things of the same value, it gives you 0. That's why no hypothesis is true when it is 0. The operator here is division. It's division. When you divide two things of the same value, it gives you 1 if it's the same. So here now, the confidence interval must not cross 1. That's what I said. I didn't say 0. That issue of 0 is when you are looking at mean, difference between mean. When you do your t-test, you look at the confidence interval. But when it comes to odds ratio and relative risk, it is 1. So the confidence interval does not cross 1. Can you see? Is it clear or is not clear? Are you confused?
Yes, I understand.
It's clear, right? So the confidence interval does not cross 1. Between 5.067 to 35. Is there any 1 there? If let's say that where 5 is 0.5 now, 0 point something, then for it to move to 35, it will have crossed 1 on the scale. If we are counting, they say a range of value from this to this. If you start from 0 point something, before you can reach 35, won't you reach 1? You reach 1. Remember. Okay, stop sharing. Let me go back to my slide. I explain for that. Stop sharing. Thank you.
Thank you, sir.
Welcome. Thank you. So look at what you just shared. Now let's move further to explain some things. So in the interpretation, as I've said, if the relative risk or odds ratio is close to 1, it means there's no association between exposure and development of disease. A relative risk or odds ratio greater than 1 indicates a positive association between the exposure and the disease. A relative risk or odds ratio less than 1 means the exposure is associated with the less disease and may be protective. The relative risk or odds ratio is often reported as a single number followed by a confidence interval in parentheses, that is in bracket. If the range of confidence interval include 1, then the result is not statistically significant. Look at, look at this diagram on this right side. Look at that line is 1. That is a border. If the relative risk is less than 1, it means that the exposure is protective, is less than 1. It means it's protective. If it's greater than 1, it means that that particular exposure causes the disease. Neither greater or less than 1. So it means that there's no even risk, there's no even association. Maybe let's the next one. So let me explain the significant interpretation of that significant here. So let's say that vertical line is 1. So when you give a confidence interval, this black along the horizontal, those black something mean the odd ratio. Then the lower value of the confidence interval is the beginning of that line. The end of it is the upper value. So it's possible you have a range of value. It's from 0 point something to 0 something is that not reach 1. Another one from 0 point something to anything after 1. After 1 can be 2, can be 3, can be any figure. The third one is from 0 point something up to after 1. Then the last one is from anything after 1 to anything after something, anything after 1. So you see, the ones that are not significant are the ones that the range of value include 1, crosses 1. But the ones that are significant, once the range of value, you cannot see 1 there, significant. Is it clearer now?
Yes, sir.
Are you sure? Somebody,
So as long,
you see, yes, sir, you are laughing. What do you say?
is it that as long as 1 is involved?
But this is echoing. It's because you
Yes,
are
as long
using
as
two
1 is involved.
devices.
I reduce the volume of 1.
What do you
So
say?
as long as 1 is involved, it is not significant.
Yes, in the range of value. If I want to be involved now, it has to start from the lower value, has to be 0 point something. You know, for something to cross 1. So it has to, that should is less than, a value is less than 1, then the other one is greater than 1. That's why that's the lower value is less than 1, the upper value is greater than 1. That's why 1 can be involved in the range, right? If the thing starts from 0 point something to 0 point something, it does not reach 1, it's significant. If it start anything after 1, maybe it can be 34, it can be 3, it can be any figure. Anything after 1, of course, it will end somewhere after 1, is significant. It is when it starts from 0 point something and end anything after 1 is not significant. So is it clear now?
Yes, sir.
Sir, but I have a question.
Okay, ask your question.
Yes, sir. So from the, if it's less than 1, if it doesn't crosses 1, it's still significant. If it's
Yes.
more than 1, as far as it
So
doesn't
listen.
cross 1.
Listen. When you say less than 1, you know you are talking about 3 figures when you are putting. So if it is less than 1, as per odd ratio or relative least itself less than 1, and the confidence interval does not cross 1, is significant. If it is greater than 1 and the confidence interval does not cross 1, is significant. Whether it is less than 1 or is greater than 1, the value, and the confidence interval crosses 1, is not significant. So go on. Go on.
Yes, sir, I understand to that point. So my question now is, does that mean those that are less than 1, probably they don't have the lung cancer due to smoking? Is that what it implies?
Yes, if it's less than 1, the confidence, and if the odd ratio or relative risk is less than 1, and at the end of the day, the confidence interval is less than 1, it means that smoking even protects against lung cancer. It means that it's even people that are not smoking that are having more lung cancer. I don't know if you understand me.
Yes, I understand now.
But if it is greater than 1, and the confidence interval, all of them, the range of value does not cross 1, it means that the people that are smoking are more likely to have lung cancer. So when the confidence interval, or when the relative risk or odd ratio is less than 1, it means that particular exposure you are talking is protective. And mind you, when you are running the analysis, you of course is the people, if let's say you are calculating with hand, is the risk among the exposed you put at numerator and the risk among the non-exposed at denominator. Imagine you put the risk among the exposed numerator and the non-exposed denominator, and it's not less than 1. What is telling you is that the risk among your exposed you put as numerator is smaller in value than the risk among the exposed, not exposed. That shows that the people that are not exposed have greater risk. I don't know if you understand me now.
Yes, sir. Very well. Thank you, sir.
That's great. Any other question? So let's talk still further about a lot to know. So odds ratio is a proxy to relative risk in the sense that you only calculate odds ratio when you cannot calculate relative risk and you still want to know the risk. You are still estimating the risk, but you are using odds ratio instead of relative risk. It's just like if the HOD is not around, you are the lecturer under the HOD, you can say, oh, go and represent me in that meeting. Let's HOD now is the relative risk, is the real person we want, is the person that's supposed to go to maybe board meeting. Because we want to measure, we want to quantify risk. It's actually relative risk that will help you quantify the risk. Odds ratio cannot quantify like relative risk. But when you cannot calculate relative risk, you now use odds ratio instead. Just like if the issue is now, you have to send somebody to represent. In a situation when you cannot calculate relative, you cannot calculate odds ratio. You cannot say, no, you cannot use relative risk instead of odds ratio. But you can use odds ratio instead of relative risk. Because just like imagine now you are supposed to go for one meeting as a lecturer meeting. And I say, hey, HOD represent me. Is he normal? The person normal? No. Your superior cannot represent. You can only represent your superior. You imagine someone go, oh, my junior is not around, I come to represent. Nonsense. It's not possible. But we can say my boss is not around, I came to represent. So now let's look at those. When the probability of an event happening is rare, the odd and probability are close. Let me demonstrate for you now. This is because A is much smaller than B, and so A, you remember, if what we mean by A is much smaller, look at the one we did. Among the disease, among the exposed, if you remember, the first one we say 25, 475. 25 is A, 475 is B. Which one is bigger? 475 is bigger than that 25 are A. If the disease is rare new, let's say the disease. So when the disease is rare, okay, you know A plus B is the total along the row, which is, let's say 500 in this case. And we now have, if the disease is rare, instead of 25, you can even have 5. How many people they have the lung cancer among the people that smoke? They may even have only 5. The disease is rare. So in that situation, A over A plus B can be just say A over B, because the contribution of A plus B, A to A plus B is small. Can collapse that and say that is approximately A over B. The same thing we see. Even when the disease is there, this one will be even worse because this one are not exposed. They will not even, the people that will not have the disease is very small also. Like for example, when we even have 5 plus now 90 something, 95. You may even have 1, which is 1, the other one will be 999. So if you see 1 over 1 plus 999 is not too far from 1 over 999. Just remove the other one from it. So making C over C plus D is approximately C over D. You know, that is the A over B now The first one you calculated will be the risk among the exposed. The second one is the risk among the non-exposed. If you now say relative risk is risk among the exposed over risk among non-exposed, making A over B divided by C over D, that would be A times D over BC. That's the formula of odds ratio. And you see now, mathematically we have proven that if the disease is rare, the odds ratio, relative risk approximate. So when the disease is rare, the relative risk of, if you do a cohort study and calculate relative risk, and you do case control study and calculate odds ratio, the answer, what you get will be almost the same. But the disease is rare. And it's a very natural, good natural way of relieving headache, because all cohort study is the most expensive study. Cohort study is more expensive than experimental design, in the sense that you have to follow up for many years. And the process of following, you spend a lot of money. You have to, when you bring your participant to begin to elicit, maybe they have developed what you are talking about, you have to give them money. You have to pay for their transport. You have to pay for their time. For them to get involved with, they did this heart study, Birmingham heart study, over 40 years. Imagine, to follow people up for 40 years before they analyze. It's not small money. They are government spend on that thing. So cohort study is usually very, very expensive. And when the disease is rare, the implication. You can even follow up for 100 years, you may not see one case of the disease. That shows that all the effort you have put is nonsense. But when the disease is rare, so since even what you are looking for, you can get through case control study. That is, the value of relative risk will be almost the same thing with the odds ratio. That is, odds ratio, which is a proxy to the risk, will usually give you almost everything what you will have gotten if you have done a cohort study. You just do case control. You look for the case of the disease, the few cases you've seen, and do your case control and calculate the odds ratio. The odds ratio approximately relative when the success are rare. Successes when I say successes, using statistical language, when the disease is rare. Odds ratio is sometimes referred to as approximate relative risk. Look at this table, demonstrates the same thing. And I will still show you in the one we have analyzed before. Look at P. Look at relative. This P is probability. Just talking of the probability, the risk. The risks. Then so relatively, when you compare the two risks, when the risk, can you imagine two groups? The exposed, if the risk is 0.1 and non-exposed, the risk is 0.05, the relative risk is 2 and the odds ratio is 2.11. If the risk is 0.3 among the exposed and non-exposed 0.15, the relative risk is 2. The odds ratio, can you see, 2.42. If the risk among the exposed is 0.5, among the non-exposed is 0.25, the relative risk is 2. The odds ratio is 3. If the risk is 0.7 among the exposed and 0.35 among the non-exposed, the relative is 2 and the risk odds ratio is 4.3. In which of the row is the value of odds ratio closest to the relative risk? You can unmute and talk. In which of the row? Because there are 4 rows. What do you say?
0.1 to 0.05.
Yes. So when the risk is very small, when the risk of the disease is very small, the value of relative risk approximate, and odds ratio approximate that relative risk. So if you get someone say the risk is 2.00 and 2.11, It's not almost the same. But when the disease is high, the disease is high, the burden of disease are like 0.7 among the exposed, 0.35 among the non-exposed. Even though it still give you all of them, still give you the same relative risk of 2, because it's telling you that the exposed are more likely double not exposed. But as the burden of disease increases, the risk of disease increases. You see that if you calculate relative risk, odds ratio instead of relative risk, the value you get is far from the, what you're interested in is the risk, which is the 2. But because the disease is very high, the burden of disease is very high, the relative risk you calculate is too far. Something that is 2 will give you 4.33. Can you see now? So when the burden of the disease, the probability of the disease is very low, the relative risk, the odds ratio value approximate that of relative risk. Maybe before this thing is saying the same thing, this graph, maybe before I say that, let me go back to, I want you to, these 2 scenarios we analyze, those one for, we are able to calculate both relative and odds ratio. Where do you think the disease is rare? By looking at that table, Look at this one. The first one talk about, look at it very well. Where did it? If you want to know the burden of the disease, look at it. Here is 30 out of 150, 1,500. So the prevalence of the disease here is 30 over 1,500 times 100. So if you know, that's the total for, because the total that have lung cancer is 30. The total, all of them is 1,500. So the prevalence of lung cancer is 30 over 1,500. Compare with this one. This second scenario, where we have out of 200, 50 have the disease. So in which of them that is the burden of the disease higher? On Mount and Talk.
Sir, this second one.
This second one, yeah, you're right. This second one, 50 over 200 is far higher. If you calculate, that's 25%. But the other one, 30 over 1,500. What is it mean? It's just shaking, it's small. Now, that shows you cannot tell me that the disease is rarer in that one than in this one. Look at let's compare their odds ratio and relative risk. This one that the disease is higher. Look at odds ratio is 30.5. Relative risk is 8.14. The disease is higher here. Look at odds ratio is 30.5. Relative risk is 8.14. Then let's look at this one. This one that the disease is, the body is smaller. The odds ratio, the relative risk is 10. Odds ratio is 10.47. Which one has the closer value? Between the odds ratio and relative risk. This one.
This one.
This one, because this is just 10 and 10.47. And because the disease is rare here. But that one, because the disease is not rare, it's much. So there is much distance in the value of the odds ratio and the corresponding relative. Can you see? It just validates what I told you. So when the disease is rare, the odds ratio, value of odds ratio approximates relative risk. So there's another dimension here. When the event occurs equally in both the exposed and the non-exposed, relative risk and odds ratio will be the same, each of them 1. That is, what it's telling you is that if you look at those tables, once you have the number, the proportion, the percentage above and below between the exposed and non-exposed is the same. The relative risk will be 1. If it is odds ratio, it will be 1. I don't know if you understand that. Relative risk will be 1. The odds ratio will be 1. That is, if the disease occur both equally among both exposed and non-exposed. So in that situation, that is when relative risk and odds ratio are the same. But the odds ratio is always further away from 1 than the relative risk. Just like the way we have demonstrated from the outset when we started, the value of odds and risk. Risk is probability, is between 0 and 1. It cannot be less than 0, it cannot be greater than 1. The odds ranges from 0 to infinity. I did say something when I was reading that. That's why people that play, that bet, which one do they use most? The people that bet for ball. Is it risk they use or odds? The guys should be able to give me the answer. Because ladies don't bother about it. Yes? Farouk. If you are talking, you have to unmute. Nobody. Now, the one lady want to answer. What's the answer? Which one do they use? Those people that bet for football.
I just asked my brother, it's odds.
Yeah, your brother was there. Yeah, it's odd. It's odd.
Yeah.
And the reason is very simple. If you know, we have demonstrated from the outset that the range of value for risk is between 0 and 1, is limited. But for odds, it's between 0 and infinity. Let me go back there because some people were not here when we started. Look at what? Look at it. Probability is the risk here. Risk is the same thing as probability. So if you look at it, when the odds is 0, risk is 0. Now, though here we are not talking of ratio, but we are talking of risk and odds, just for you to verify. So if you look at it now, when odds is 0. If you look at the value between the different odds now, probability rather risk, and compare with odds, you see a wide range of value. So when the people that play football, that watch football, what they do is that they calculate the probability, the chance of each team, each team. Is it team we call them? Is it company? What do they call those when they say playing for a particular team? So they will calculate the chance of each team winning, each club winning. So when they calculate, if they use probability, the value will be too close. They cannot make decision. When you say 0.9, 0.91, 0.92, 0.89. So they cannot make decision. But if they convert it to odds, they will see difference. So the one that is 0.9 and the risk is 0.9, if they convert it to odds, it gives you a value. The one that is 0.91, when they convert it to odds, the difference you see in the odds will be different. So they can see the difference in the value of their odds because the odds has a range of value from 0 to infinity, while the risk has a range of value from 0 to 1. That's why they use odds to bet rather than risk. Now, this last one I'm trying to explain. The odds ratio is always further away from 1 than the relative risk. When relative risk is less than 1, odds ratio is always less than relative risk. Then when relative risk is greater than 1, the odds ratio is greater than relative risk. So just like the way the risk is a narrow something, the odds ratio has a wide range. It's the same. Odds has a wide range. It's the same thing. Relative risk, the margin is short, while odds ratio, the margin is wider. So let's look at, for example, look at this graph now. That's what it's trying to demonstrate. Logic behind it. They plotted for maybe each scenario, just like what we did, we plotted odds ratio in the vertical. Risk ratio, when you see risk ratio, it's the same thing as relative risk. Risk ratio, which is relative risk at the horizontal. Look at their graph. Let's look at the red one. Let's look at the red one. I want to look at the one that crossed as a strategic place. And let's just look at the red one. Look at the red one. When the odds ratio is 5, can you see? Look at it. The odds ratio is 5. Where does it cross that line? It crosses along the horizontal. Where does it cross that line? Where it crosses that red, what is the corresponding value of relative risk? Okay, let's start with the relative risk so that we follow the sentence I gave you before. Let's look at the value where, look at the relative risk 1 here in the middle. Let's look at the value of relative risk 1 is 0.5. Is 0.5 is less than 1. Is that not so? Let's see where it crosses the red line. It can be any of them we choose, the red line. What is the value of odds ratio? Is less than 0.05. It's less than 0.5. Is that not so? If you look at it, if you draw, I can use my this now. Look at what I'm saying. Here, relative risk at 0.5, which is less than 1. If you look at where does it, let's trace it to this red something. What is corresponding odds ratio? Is it not less than 0.5?
Yes, sir.
Less than 0.5, sir.
Yes. Less than 0.5.
Yes. So when odds ratio in relative risk is less than 1, the corresponding value of odds ratio is less than relative risk. But let's look at here. Let's check 2.5 here. When odds relative risk 2.5, sorry, it cannot be 2.5. Anyway, it can be 2.5. It's no way. It's not risk. It's relative risk. 2.5. Let's draw. Let's draw it where it reaches the same. In fact, it's outside. Let's use another. Let's use this one. Let's look at that green graph. When relative risk is 2.5, let's look at the corresponding value of what is it? Is it not greater than 2.5?
Yeah. Yes.
Can you see now? So when in this situation now, the relative risk is greater than 1, the corresponding odds ratio is greater than relative risk. When the relative risk is less than 1, the corresponding odds ratio is less than relative risk. So you see, so the relative risk, it has a range of value wide. Why the whole narrow rather relative risk, the odds ratio has a wider value. So don't worry, when you start using this, you'll be able to understand. Relative risk and odds ratio are more similar when the baseline risk, reference risk, or the probability of the event in population is small. We have already said that one. When the probability of the event is very small, the value of relative risk and odds ratio will approximate. If you want to check now, anyway, just leave that one. I think we are. So there's a way, many a time, because relative risk is core study is very expensive. Many people don't do it. It's very expensive unless some organization or government is funding it. But case control study descriptive study is easier to carry out because it's not too expensive. So that shows that most of the time, you'll be seeing odds ratio more than relative risk in population. And so intelligent people now came. You can actually convert the value of odds ratio to relative risk. That's what you have here. So don't bother yourself. I don't know if this last slide is useful for you, but this is more of like epidemiology. But where's the brush? Let me clean this. This one is the criteria for judging association. Let's just go through and end the lecture. The criteria for judging association. When you know these relative risk and odds ratio, they are measure of association. There is a third measure of association, but we don't talk about it often unless we are doing survival analysis. That is a survival ratio. Now, survival hazard. Now, let's look at this. When you quantify your relative risk 2.5 means that the people that are exposed are 2.5 times more likely to have the disease than people that are not exposed. How do you judge it? For the fact that so you get figure, what does it mean? It just doesn't mean that that thing is the one that is causing it. So when you want to judge to see, you are judging association. The most important, this criteria was developed by Hill, one British physician, and has been used. See, 9 criteria used, and they are arranged according to importance. The most important is number 1. The way they are arranged is according to the importance. Temporal sequence. Before you can say there's an association, this thing is the one that's causing this disease. This exposure is the one causing disease. There must be an association. There's an association. There must be a temporal sequence. Temporal sequence means that did the exposure precede outcome? If you say that, oh, obesity is a risk factor to hypertension, do you prove that that person was obese before he developed hypertension? Or you just said it? Because if you just go to the people now, go and measure their blood pressure, so measure their body mass index, and now constabilite. You say these are hypertension, these are not hypertension, these are obese, these are not obese, and now constabilite and say, oh, the obese people are more likely to have hypertension. It doesn't make any sense, because in that type of study, cross-sectional study, you cannot establish temporal sequence. That is the most important effect. The second one is strength of association. How strong is the effect measure? That is, if something is 20, it's stronger than when 10. When we say relative risk 10, compared with relative risk 2, it's not. So when the thing is big, is a pointer that look at. Then the next one is the consistency of association. Has effect been seen by others? So what it means is that consistency, if people do the same study, they get the same thing over and over. Then the next one is biological gradient. Those respond gradient. Will you be able to analyze that? The more people are exposed, the more the risk increases with the level of exposure. For example, now lung cancer and cigarette smoking. Some people, they smoke for long, and they also smoke more stick than others. Were you able to demonstrate? You demonstrate that, okay, people that smoke for 10 years, when you run the analysis, is the association stronger than when you use people that smoke for 5 years? Then people that smoke maybe 1 pack per day, when you compare the association with when you people that smoke only less than 1 pack, is the association stronger? That is what we call dose response relationship, which is biological gradient. Then specificity of association. does exposure lead only to the outcome? You know that one? Though, if that's why it's not, though it's not the most important thing, but if they say that this thing is only this thing, does the association lead only to outcome? That is, that particular thing, that's the only thing is causing. When they say tobacco bacteria, tuberculosis bacilli, it's only tuberculosis is causing. If it's causing other things, you cannot always say that it's the one causing tuberculosis. So that one also. Then biological plausibility. This one doesn't make sense, biological sense. Sometimes if you're a doctor, you are practicing, and they just say something, you cannot even place it biologically. How does it cause it? If you cannot be demonstrated, because statistics can give you anything. You know, association can just come. It's just like I just saw one of you, I saw one man, you are just passing. You just came out of hall and I said, oh, you have something to do with that person. It doesn't, it doesn't make any logical sense unless if you can demonstrate that you're always seeing them. Not that you want the association, anything can just happen. So number 7, coherent with existing knowledge. If it's consistent with existing knowledge. Though if you look at it as you are going, and it's not as important because sometimes coherent with existing knowledge, most of the breakthrough in this thing, initially it doesn't even make sense. It doesn't, the people say, we have not heard of this. Just like when Albert Einstein came with his law of relativity, he shook the scientific world. And in fact, they rejected it and forget about that nonsense. But later, it found out to be true. So sometimes it can be something, it may not be coherent with existing knowledge. And that is why it's not so important there, because though it's part of what you use to check also. Because someone shows you something, you cannot, does he coherent with coherent? Is it coherent with existing knowledge? You cannot. Then experimental evidence. Is there any experimental as a randomized control trial being done? You know, if you look at it now, that experimental evidence does not mean that if you look at it, it's lower down. You know, many people say they say the experimental design is superior. Forget about that nonsense, because there are some situations where you cannot do experimental design. Imagine now, you did during COVID-19, that's you want to see if this drug works, this one does not. You now give some people placebo in COVID-19. See, when people are looking for vaccine, that's you give some vaccine, you will not give will die. You cannot do that. There are some experiments you cannot perform because of ethical reason. So that's why as it being control as a randomized control between that one is when it's possible. The last one is analogy. Is the association similar to others? So that's just end of the lecture. I don't know the lecture or workshop. Or any question? There's no any question.
No, for now. Thank you very much, sir.
Okay. Good night, everyone.
Thank you.
Thank you.
Thank you.
Thank you, sir. Good night, sir.
If I remember my question, I'll ask later.
You remember question?
If I remember, I'll ask later. No, I forgot. Thank you, Prof.
Yeah, thank you.
Thank you.
You're welcome. Good night.